Hello, this is Mr. Stansbury. I'm going to take you through the 18A notes on correlation. At the end of this, you should be able to say, I am able to find how two variables are associated or related, positively, negatively, or no correlation, as well as linear or not linear. All right, so let's take a look. We got positive, negative, and no correlation here. So first one, positive correlation, is basically if you draw a line of best fit through these points here, it should go up as we go from left to right. Okay. With the negative correlation, if you draw a line of best fit, it should be going down or have a negative slope as you draw the line left to right. And then the no correlation, there's no line of best fit for this. It's just kind of like a spray of data there. Okay. All right. With that causation, causation is one thing that affects the other. Okay, and then when variables are related, so that if one is changed, the other changes too. This is called a causal relationship. All right, so when one piece of data affects the other. All right, let's take a look at something else here. Bring this back up. And let's try, let's try koala bear today. Why not? There we go. Okay, so we are going to find the line of best fit for the following points. Okay, there's a couple different ways to do it. One is by eye, where you just simply just pick 2 points. And so let's try that one out first. So we're going to pick 2 points which we think are going to probably be the best fit. So probably this 1, 2, that line there. Let's see. I can't draw on there. That's all right. So 1, 2, and then maybe as we go through here, maybe the 9, 8. That looks like there's about the same on top as below. So isn't it a beautiful straight line? Yes. So let's use these 2 points, and we'll use those 2 points to figure out what the line of best fit would be. Okay, so this is the by eye method. So what we're going to want to do then is we'll draw the 2 points, 1, 2. Let's use a better color than that so you can see. So we've got 1, 2 is 1 point, and then the other point is 9, 8. Okay. So first thing you want to do is find the slope of this thing. So we go 8 minus 2 over 9 minus 1, which gives us, what, 6 over 8, which is 3/4, and that's our slope. So that's part of it. And then what we want to do is we want to use either slope-intercept, or probably the better choice is the point-slope formula. So that's y minus y1 equals m times x minus x1. Okay, and if you don't remember that, you're going to want to write that down somewhere so that you don't forget that one, because this is going to be pretty handy. So we're going to use our new slope that we just found, which was our 3/4, right? And then we can choose either one of these 2 points to plug in for our y1 and our x1. I'm going to choose this 1, 2. I like those numbers, seem a little bit nicer, so we'll go y minus, the y value is 2, so y minus 2 equals 3/4 times x minus the x value is 1. So we get y minus 2 equals, distribute this through, and we get 3/4 x minus 3/4. And then our last step is to get y by itself, so we add 2 to both sides. And we get y equals 3/4 x. It's going to give us plus 1 1/4. All right, so that is the by eye method to find the equation of the line. Okay, there's also another more effective way to find that. Oh, nuts, I wrote that all on here. I'm going to erase it really quick so we can get rid of that. All right, so we don't need that. The other way is actually with the graphing calculator. So I'm going to bust out the graphing calculator here, and we're going to do this same thing by using our graphing calculator. All right, so that was the by eye. Here we go. Linear regression is what this is called, and we use our graphing calculator. So here are all the points that are over here. All right, so what we're going to do here is use our graphing calculator to actually find the best line. Okay, and it's again called linear regression. So what you want to do on your graphing calculator is turn it on first. There we go, and then you're going to hit the stat button. Okay, so you hit stat, and what we want to do is we want to enter new information in. So we want to edit. So it's on edit, and it's going to already highlighted for edit. So we're going to push enter, and it's going to give you a bunch of lists. So what we want to do now is we want to put all the x values on the first list and all the y values on the second list. All right, so let's enter those in. So we got 1, and you can just push enter and it'll just naturally go down for you. 2, and these are all the x's that we're putting in here. 5, 7, 5, and it doesn't even matter what order you put these all in, as long as you keep all of the ordered pairs together. So let's see where it's probably easiest just to put them all in order so you don't mess them up. Let's see, 9 and 10. All right, now that I've got all my x's in, I'm going to go over to the next. There we go, to the next list, and now I'm going to put all the y's in. So there's 2, 4, 4, 4 again, 5, 7, and 7. Let's see, and then we're 9, 9, 8, 8. 9, 9, 8, and 8. And we should, if you'll notice down here, these last two should match up, 10, 8. And if you go through and look at any of these are all the ordered pairs. So we know we got them in right. And then what you're going to do now is go back into stat again. So we push the stat button, and now we're going to want to calculate our linear regression, we call it. So we're going to arrow over to calculate. And then here is linear regression right down here for this calculator. It's number 4. And we're going to push enter. And say, okay, you want to find linear regression in this form? It's like, yep, that's what we always want to do. Push enter. It'll think for a second. And here is your equation. Now it says y equals ax plus b, where a is 6.95 and b is 1.92. So our equation is going to be y equals 0.695x plus 1.92. So y equals, let's see, 0.695x plus 1.92, I believe is what it was, isn't it? 0.695 and plus 1.92. So there is our a little bit more accurate version of the line. And again, that's all done with the calculator. All right. Okay. One last quick thing, and that is just a few little definitions. In case if you forgot, the independent variable is also called the input, which is the x value. So the x is the independent variable, and the dependent variable is the output, which in this case is the y, and it depends on the input is how I always remember that. So you put in the x and out comes the y. All right, so this is all there is for 18a. You should now be able to say that I'm able to find how two variables are associated or related, positively, negatively, or no correlation, as well as figuring out if it's linear or not linear. And again, linear means it's a straight line, and not linear means it's a curved line. All right, if you have any questions, please ask. Thanks.